I want to show my work today, which investigates the interplay between cystatin C and cathepsin B during pancreatitis. As we all know, pancreatitis is a self-digestion of the pancreas by its own digestive proteases. Under physiological conditions, secretory and lysosome proteins are sorted in the Golgi apparatus and packed separately in different compartments. A pathophysiological stimulus leads to blockage of secretion. Cathepsin B and trypsinogen co-localize. Therefore, different hypotheses exist. First, that there's a fusion of lysosomes and thymogen granules. Second, that there's a missorting of the cathepsins in the Golgi apparatus. And we think that there's a third one, that there's activation of pre-existing cathepsin B in the secretory compartment. First of all, we wanted to know where cystatin C as well as cathepsin B are located. And we could show with a marine model of pancreatitis as well as human samples of chronic pancreatitis patients that the inhibitor cystatin C is exclusively present in the secretory compartment, whereas cystatin B was only detected in the cytosol. Active cathepsin B was also found in the secretory compartment. When we had a look on the pH-dependent activity of cathepsin B in the thymogen granules, we could observe a significant increase of the cathepsin B activity after 1 hour disease onset, and no difference after 8 hours serine stimulation compared to the resting conditions. So we can say there's a pH and the time dependence of the enzyme activity, and these results also suggest that cystatin C is not able to inhibit cathepsin B under pathological conditions. But if we give the cytoplasm to the thymogen granules, we observe an inhibitory effect of the cathepsin B activity under neutral pH, but not under acidic conditions. The reason for this is that the cytosol still contains the inhibitor cystatin B. This suggests also that if there's a pH-dependent inhibitory capacity of cystatin C, and it also raises the question why cystatin C, which is present in the secretory compartment, is not able to inhibit the cathepsin B. For this, we could show in vitro experiments that trypsin can degrade cystatin C over time, and there's a generation of 2 distinct cleavage products. Furthermore, we observed a significant increase in stabilization of the cathepsin B activity in the presence of processed cystatin C even at neutral pH. When we had a look on the pancreatic injury, we could show with HE staining as well as with serum amylase and lipase activity that there is a significantly increased pancreatic injury in cystatin C deficient mice after 24 hours. Moreover, we also observed a significantly higher apoptosis in cystatin C deficient mice after 8 and 24 hours serine stimulation. To summarize this fast, processed cathepsin B is already present in the secretory compartment of asthenocytes. Under physiological conditions inhibited by cystatin C. Acidification of secretory vesicles reduces the inhibitory capacity of cystatin C and permits cathepsin B to activate trypsinogen to trypsin. Trypsin degrades cystatin C, which additionally stabilizes the cathepsin B activity. So we can say cystatin C inhibition of cathepsin B is a crucial protective mechanism of the pancreas against the effect of prematurely activated digestive proteases. Thank you for your attention.